Can you see my screen?
Yes.
Excellent. Okay, so we've got a few different windows here. What I have on the top left is just a window showing BTOP. So I just have my NVIDIA GPU and my local machine there. And as you can see, it's sort of doing nothing. I don't even have a video game going on or anything like that. And we're just going to use that to show like the GPU is running and it's doing things when we do our demo. And I've just got a terminal down here and then VS Code open with some code. So for today's demo, we're going to be solving a routing problem, a vehicle routing problem, using cuOpt's routing solver and their Python API. So we've got some routing input. It has different jobs, deliveries or pickups that it needs to make. This is all fake data, so the Ants Pants Cafe. I don't know if that actually exists somewhere. But each one of these is a location on a city that we have to make a delivery to. We also have a single vehicle, and one of the things we're going to change in our model is how many of these vehicles. We can think of this as a capacitated vehicle routing problem. So we have a depot and we're making deliveries. And one of the questions we want to answer is like, how many of these vehicles should we actually schedule for that day? And how would that impact our KPIs? So I have just this one vehicle, and what we're going to do is essentially just copy it as we run the model. So that's what our input looks like. This is pretty sort of standard Nextmv routing input. The next thing we have is the actual model file. And this is a Python script using the cuOpt Python APIs. The important parts are in this main here. And so you can see we've got some Nextmv options being loaded. So this is already sort of a Nextmvified model. All of the cuOpt logic is down in here. So we're creating cuOpt data frames and a routing data model. And we're adding locations and capacity constraints and that sort of thing. So you can see it's just sort of a standard cuOpt model that you'd see in their examples. And then we set a time limit, and we copy the number of vehicles based on the options that are passed to the model. And at the end, we solve it, and then we write next JSON output that we can pull solutions and statistics from. So pretty simple. So what does this look like when we actually run it? Get my document open. All right. So we'll just, and you can see I'm running this inside of a dev container. So we're using the base images that NVIDIA provides. And so I'm just going to run that script with one of the inputs that we've shown. And what I should see here is that it's actually starting to use my little GPU over there. And yes, we can see the GPU is spiking and I get a ton of output. So that's all well and good. The question now is really, how do I put this thing into a production environment, and how do I share it with people, and how do I experiment with it? And so that's where this union of the technologies comes in. So the first thing I'll show is what we call an app YAML. This is essentially a manifest for my cuOpt model. And it defines what type of an application. So this is a Python application. What image does it use? It uses this cuOpt image. What Python required dependencies are there, what architecture is there, what version of Python, and so on and so forth, as well as what are the files that go into it. Down here, I have an options section, and these are the things that I can set as either command line flags or in my production environment. I can make changes to these to get different outputs and different configurations. And so here, what I have done is defined both a time limit. So how long am I going to allow cuOpt to run for? How many seconds? And how many vehicles do I want to run with? And so this allows me to do some validation on what those options are, as well as provides user interface components that lets me change them in the operational user interface. The other thing that we have is an app.py. And this is super exciting because what it allows me to do is make my development environment look more like my production environment. That's one of the best things we can do when we're developing these kinds of models, is develop an environment that's easy to push into a production environment. So I can run things locally, and it looks very, very similar or the same to what it looks like when it's in a production setting. So what you can see here is I create a local application. So this is using Nextmv's open source libraries or for application management. And I'm going to do local runs, and those will exist and be managed locally within this directory, and then I can sync those into cloud. So that's what I'm going to show. So first thing we're going to do is we're actually going to make a few runs. So let me open this up, and I'm just going to do Python app.py. Oops, helps if I spell Python correctly. And you can see here it's kicking off a few different runs. And again, I should see my local GPU spiking a little bit to actually account for those runs. There it goes. And once that's done, I'm going to go back to this app.py, and I'm just going to change it so it's actually going to sync these runs from my local machine to my remote machine. This is super nice if you are doing a lot of local development, but you're still operating within some kind of a production or a team environment, and you're trying to share results or compare things or get visuals and whatnot. So that's done. So I'm going to now run that same command. And what I can see is that it's found 3 local runs, and it's now syncing these up to Nextmv. That's going to take just a second. All right. So these should now exist in Nextmv console. So let's go over there and see where they are. So this is the entry point for my application. It sort of gives an overview of things that have happened and versions and runs and stuff like that for this particular co-opt routing application. I'm going to go into the runs view, and I'm just going to refresh this. And what I should see is that I've got a few successful external runs that have synced from my local machine onto the remote platform. So that's cool. If I click into one of these, I can see that it has the input, the output, all the metadata and logs and so forth from my local machine that have been copied up there. I can also push that application so that now I can run it remotely. So all the runs I've done so far have been done on my local development machine. So the question is, how do I actually push that into a managed environment to get it to run in a production setting? So for that, I'm just going to run Nextmv app push and give it the app key, the app ID, and it will use everything, all the information that it has in that app.yaml, i.e. what runtime is it, what language is it, what are the dependencies, so on and so forth, and we'll package it up and send it off to Nextmv. And so it's bundling, it's looking at the manifest, and it's pushed it, and so now it's live. And so that's sort of a one-step deployment, which is pretty quick for something like this. If I switch back to console, I can see that there was a recent push of the application. I could cut a new version of it. So I could go into here and give a new version, and I can see there's a new push that I just did. And I could set my production instance or a test instance or any other instance of this model endpoint instance to use that new version. I can change the configuration, so the time limit in vehicles, I can set the defaults for those, and I can choose different GPU accelerated hardware, or if I'm not using GPUs, I can go back to CPU just through this dropdown. So it's fairly easy to add the GPU acceleration and to set the model configuration from there. So once I'm actually doing these runs, one of the things I might want to do is compare different configurations directly. And so, here we've got some where we've run for different time limits with the same number of vehicles. So like these two, and what I might want to do is compare those two runs. And so we have this sort of side-by-side comparison of different runs with different configuration. On the left, I'm running 1,000 jobs, 100 vehicles for 10 seconds. And on the right, I'm running it for 5 minutes instead of 10 seconds. And so I get different objective values, and I could view the map and so on and so forth. So I can do this sort of direct comparison of both the run statistics and any visual assets that I put with those runs. And so that's useful for sort of side-by-side analysis or sort of anecdotal experimentation. The question then becomes, if I'm developing an optimization model that I want to put into a production environment, what is the optimal configuration for that thing? How many vehicles should it have, and how much time should I give it, in this instance? For that, what I can do is I can run a scenario test. And before I explain this, let me go back here and just create a scenario test. So you can see we have this interface where you can define a bunch of different options. So I can say what inputs am I using, and I can add all of those time limit and vehicle options here, and it will run all of them. If I clone this existing one, this is the configuration for the scenario test that I ran before today's tech talk. And so you can see I'm running it with a bunch of different time limits and a bunch of different vehicle counts. And so what it's going to do is run all of these and give me essentially a pivot table and data set that I can use to choose the configuration that I want. And you can see here, we're varying from 100 to 300 vehicles with different time limits, and we're minimizing costs, so lower objectives are good.